Hey guys, Angel here. And before we get started on this question, I just want to give you a little tip, and that is to be an independent student before you become interdependent. So a lot of people, when they start this course and a lot of other science courses, they have a tendency to hop directly into a study group, and they want to find people that they can study with because they'll be under the impression that it's going to make the course just a little easier. But in reality, I always advocate, and this is only my opinion, that it makes the course a lot tougher. And that is because when you're in a study group, you have a tendency to become distracted, is a first point. But a more important point is that it actually becomes an inhibition. And that is because people have a tendency to tag team tough problems or tough concepts. They'll simply rely on one another to come up with parts of the question or of the concept, or they'll each complete a certain part of the homework. And that is only inhibiting your ability to learn. When somebody explain something to you, they'll explain it in a way that makes sense to them, but that may not necessarily make sense to you. And so what you should do when you start any course is become independent before you become interdependent. So that means go and look at online forums, look at your textbook, your professor, or I really enjoy video forums like this one, and really learn the material in a deep way that makes sense to yourself, and then that way join a group at that point that you become an independent student, have done all your homework, have done all your reading, and now really can contribute to that group with discussion. And you can also contribute to other people who may be just falling a little behind by teaching them. Whenever you teach something, you will retain it that much better. And so again, just become an independent student before you become interdependent, so that way you can really contribute to the group rather than making it an inhibition. And so the question here says, Sandy kicks a soccer ball which experiences a projectile motion with an angle of 37 degrees to the vertical. Its initial velocity is 10 meters per second, and we're looking for the peak height, the range, and the total time required for the motion. So I've drawn out a little bit here. We've got our initial velocity with the 10 meters per second, and then our angle to the vertical, and then this is our vertical plane here, is 37 degrees. So this is important because some people will directly start doing the trigonomic functions on the 37 degrees as if it were this 53 degrees. Let's say we're solving for the here we go, the vertical component of this initial velocity. So we're solving for this guy here, which would be the same leg over here. Depending on which angle we use, we're going to use different trigonometric functions. If we're using the 37, then we would want to use the sine of 37. But if we were using the 53, oh, I'm sorry. If we were using the 37 degrees, then we would want to do the cosine of 37 degrees because that's going to solve for our adjacent leg, that would be the adjacent leg of this triangle. But if we were using the 53 degrees, we would be solving for the opposite leg of this angle. So we would want to use the sine function. And so that's just something to keep an eye out for, is make sure that you're using the proper trigonometric function, and so that way don't let those little just change of words trick you. And then when you do those calculations, you get that the vertical component of the initial speed is about 8 meters per second, and the horizontal component is about 6 meters per second. And the first thing that we're going to try to solve for is the peak height. And just with this information right here, that 8 meters per second, we can solve for the peak height. That's because we can start plugging in numbers into this kinematic equation, which is V final, or the final velocity, minus the initial velocity squared, both values squared, is equal to 2a delta x. So I'm just going to erase this just to make space for us. And our final velocity at the peak height is going to be equal to 0 meters per second, because at this point the ball is no longer traveling upwards, and is because all of its velocity has been taken away from due to the acceleration of gravity, which is going to be our a right over here. So our final velocity is going to be 0 meters per second, and if you square that, it'll still be 0, minus the initial velocity, which is going to be our 8 meters per second, and we're going to square that in our calculations. And then you've got 2, and then the acceleration of gravity is equal to 10. We're going to round that up to 10 meters per second squared, and that's a negative value. I'm just going to move this over. And then we're solving for delta x. which you can just think of as h, because that's what we're solving for, the peak height. And so when you do those calculations, you'll get that a negative 64 meters squared over second squared, and then I'm going to go ahead and just move this negative 20 meters over second squared over here, negative 20 meters over second squared, and then our second units are going to cancel out, and then we're going to lose this meter unit here, but we're still going to have 1 meter unit left over, and overall this comes out to 3.2 meters is going to be our peak height, and we were able to solve for that using just the initial component, the vertical component of the initial velocity. And so just with that information, we're able to solve for the peak height. And so the MCAT book that I'm currently studying takes that initial equation that we used and just moves it around to equal this equation, which is what we can use for any projectile motion if we have the vertical component of the initial velocity and we're looking for the height. You can also use this equation, just FYI, to determine the final velocity of anything that is dropped from a certain height. Alright, so let's keep moving on. Whoops, sorry about that. Let's go ahead and keep moving forward, and next thing we're looking for is the range. And so when we're looking for the range of something, and the range is just the displacement from 0 meters to some delta x, some displacement. And whenever we're looking for that, we're going to use the equation that is just the horizontal component of gravity times the time of the projectile. And that's going to give us our range, or our delta x. However, although we have our horizontal component of the initial velocity, we don't have the total time of the projectile. So we're going to have to come back to this and skip ahead to solving for the total time of the projectile. And so whenever we are solving for the total time of the projectile, we're going to be using the equation that is delta, and on your equation sheet it's delta x, so we're going to put it as delta y is equal to the initial velocity times time plus 1/2 acceleration times squared. And we're solving for when delta y is equal to 0. So I'm going to go ahead and just demonstrate something real quick. Our projectile looks something like this, and that means we have 2 points at which the y-axis is equal to 0. A point here when time equals 0, because if the ball hasn't moved, it's not in the air, then its y displacement is 0. And there's going to be another point that after it's gone through its whole projectile, it's going to also be equal to 0 again when it hits the ground. That second time is what we're looking for when we're looking for the total time required for the motion, and we're able to get that from this equation up here, and by setting delta y equal to 0. And so we've also got our initial velocity and the vertical component, and that's because we're looking to see how long it's going to take to go up and down. So we're going to want to use the vertical component of the initial velocity. So we're going to put 8 meters per second here, and then we're looking for time, and then the acceleration here is going to be the gravity, so that's going to be negative 10 meters per second squared. And we're going to half that, and so that's going to come out to negative 5 meters per second squared. And then again, we're looking for time, or the t variable. So now that we've got that, what we can do to this part of this equation is take out a t from here. And so what I mean by that is we're going to isolate a t, and then in parentheses put what's left over. So that would be 8 meters per second minus 5 meters per second squared times t, because here this t squared, and we're taking away a t, is going to leave 1 over. So if you were to multiply this t variable by this parentheses, this stuff in the parentheses, you would get this same equation. And then now here is where we can solve for the 2 times that will make the delta y value equal 0. If you multiply anything by 0 here, you're going to get 0. So that would be one thing. Another thing is if we were to set this right here within the parentheses equal to 0, then technically we would be dividing t times 0, and we would get 0. And so that's exactly what we're going to do. We're going to take I'm going to use a different color. We're going to take this equation and we're going to set that equal to 0. So 8 meters per second minus 5 meters per second squared, t is equal to 0. Now we're going to solve for this t, which is going to be pretty straightforward. We're going to go ahead and subtract 8 meters per second. So negative 8 meters per second, and that's going to leave us with negative 5 meters per second squared t, and then we're going to solve for t. And I know that I'm kind of moving around the position of the t on from the left side to the right side to the left side again, but just it's pretty straightforward algebra. And then we would get negative 8 meters per second over negative 5 meters per second squared. So we're going to cancel out our meters, and then we're going to have, we've got two S units, one S unit on the top, so we're going to have that the total time required for the projectile is equal to 1.6 seconds. And so again, that was done by using this equation here that is on our equation sheet, setting it equal to 0, plugging in the values that we know, and simply if we have gravity and the vertical component of the initial velocity, then we can solve for t by doing some algebra, and in this case we got 1.6 seconds. And now that we've got the 1.6 seconds from the time, we can solve for the range, and when you do the range you get 9.6 meters.